Hello everyone, welcome to the last video of this session, which will be a tutorial using Google Colab. Colab is a very useful online platform by Google. You can run any notebook on it, so Google will assign you a CPU and RAM for you to run your code, so you don't need to use your local environment. And there are many libraries that you can directly import without downloading them. So before we get into today's content, I want to mention that if you have any questions during this tutorial, you could always ask in the Discord help channel, because I'm recording this video, so I cannot interact with you during this tutorial. So I hope you do not hesitate to send any questions. You could also send the questions on the YouTube video, so you can comment below. And in the description, there will be links to the website where all the materials used in this tutorial will be there, and you could download the links and upload it to Google Drive and do exactly the same way I do. Okay, and at the end of this tutorial, we will be giving out one assignment and a question. So you could try to finish it in the next 2 weeks, and it's a good practice to get prepared for what's coming next. It will be very intense, and so hopefully you could get some practice about Python and NumPy and get familiar with it, so you can better understand the next tutorial. Okay, now let's get into this notebook. So first I listed a few documentation and tutorial here for you to get familiar with some libraries like NumPy and Matplotlib. And also, if you have not used Colab before, you can check the Colab instructions here. And if you don't want to use Colab and you want to use your own computer to run the code, then you could download Jupyter Notebook, and also you could download all of the dependencies or packages you're using. So one thing about Google Colab which is unique is that it will assign you with a RAM and a CPU. You could also request for a GPU to run your code. And here's the RAM usage. I'm currently using 110 megabytes. As you do more with the dataset, you imported a lot of data and you're doing intense computation, this RAM usage will be very large, but there's a limit. So keep that in mind. And if we want to add some new code, we could always press plus code here, and it will jump out a new window for us to code. And we could also delete it. And same thing with the text. Okay, let's start. So we start by importing a few packages. We're importing NumPy. You could type import NumPy as np, so it's easier to use. Okay, by the way, if you highlight some part in the code, it might show you the documentation. For example, NumPy here, okay, it's a module and there are many usages. And we'll also import random and a matplotlib. So remember from the videos before, from the lecture sessions, I talked about k-fold cross-validation. So here is a direct package from sklearn. You can directly import this k-fold to do that. But in this demo, I will not be using k-fold, so I comment out here. I will be hand code a k-fold algorithm for our usage. Okay, then we first run this. To run the code, simply press Shift and Enter. That's the easiest way. And Okay, now here I want to import my dataset for house price prediction. And so I actually got this dataset from Kaggle, which I mentioned in the introduction session, where Kaggle holds a lot of competition. So this is actually from a competition dataset. You could also check it out. Since it's a competition, everyone has a chance to register and submit their work, and there will be a leaderboard on it. So to give you a heads up, this will be essentially how you submit your assignment. You are not submitting the assignment to me, but submitting the assignment to Kaggle and get a number, get a ranking and score. Okay, so now we want to mount our Google Drive, because sometimes we want to upload our dataset and documents on Google Drive. This is the way to import the drive and mount the drive in order to download your dataset. Okay, usually here it will be asking you for permission, and you will open your Google account and click on a password and copy that password here. So it grants Colab access, and then you can continue. Okay, after that, we'll specify the file directory and file name. This file directory is the same as this one here. So we have the training, the set testing, set, and there's a sample submission here, and this is our notebook. So this is the directory we're working on. We type it out here. We also define a file name called train.csv, which is our dataset. And we will use this NumPy function, gen from text. And the first parameter we're passing is the file location, which is file directory plus the file name here. So in Python, if you want to concatenate a string, you use a plus to do that. And the delimiter means which character to separate data in one row. In this case, it will be a comma. And data type, we load it as string first. So you could always check, see the documentation here when you push your cursor on it. And these are all documentation. You can check how to use this function. Okay, then we run this code. Next, it will be viewing the data shape. Now, for a lot of times, the data set is very large, and its format may not be so convenient for us to visualize. For example, the CSV file can be visualized using Microsoft Excel. You can directly open it and see how the dataset looks like. But in many more cases, when you are dealing with images or other multidimensional data, it's hard to visualize them all. So you need to use your code to actually visualize how this data looks like. Okay, so we initialize this data to NumPy array. Use NumPy as array and then put data. And then we can print the data.shape. So all NumPy objects or NumPy arrays had this attribute called shape. Let's see what it does. So for shape, the first thing it print out is 1461, and the second one is 81. So what this actually represents is that this dataset has 1400 rows and 81 columns. For some dataset, there can be even more numbers here to represent even higher dimensional data. And we want to print out the first row and first column to see what it looks like. In NumPy, indexing is slightly different from Python indexing. So if you say 0 here, it means the first row, and it will directly print out the first row. So we can see, okay, the first row is the list of features in this data set. And you can see the first one is ID, and there are a lot of features. By the way, if you want to if you want to know the detailed explanation of these names, it's in the materials I provided. And the last one is sale price. In this case, sale price will be our label because we want to essentially predict the sale price. And we also want to print the first column. Now, to print the first column, in Python, we would do something like this. So we will do a colon here, which means all of the data in row-wise, and 0 means the first column. But in NumPy array, we don't do multiple brackets. We use comma to separate them. So a colon still means everything row-wise, and 0 means the first item column-wise. So we're taking the first column, but all of the rows. So it will print the first column. Now, the first column, we see ID, and from 1 to 1460. So we know actually there are 1460 items or data points in this data set. So we can work with them. And each data point has these following features, with the last one being the label we want to predict. Okay, then when we are working with a data set, we want to get rid of the first row and first column. Why that is the case? It is because the first row are features, so it's not the actual data. It's something that we want to keep in mind, or something to inform us about what the data actually means. And the first column is ID. The ID is not useful because these numbers are just a representation of the row. It doesn't have any real meanings for this data point because every data point is independent. So we will extract the features out. We take data 0, which means the first row, and we create a feature dictionary in order to for us to easily look for all of the features we want to have in terms of the column number. Okay, so when you create a dictionary, you type a bracket like this, and here's a for loop. So for I feature in enumerate features, you would you should get I, which is the iteration number, the index, or and feature, which is some element contained in this array. So the enumerate function, you could check the documentation here, right? It returns one more item, which is the iteration number. And within every iteration, we will be input into the dictionary with key being the feature name and its value being its column index. So this way we can quickly look up for a column number if we have that feature name. And we then process data by extracting every row from the second row. And now we'll print a random sample to see. Here is a function we use, py.random, random integer. So within the length of this data processed array, we will be calling a random integer, and this data processed will then this array will look for the item in that index, so it gives us a random sample. Okay, so 841, which is the ID. We haven't get rid of the ID yet because we want to visualize it for now. This is the 843 data point and has these being the attributes. and also with the last one being the sale price. Okay, now we actually want to perform KNN, but as you see, some of the data here are not numbers. So it's hard for us to calculate the distance because these are not numeric numbers. So what we can do is that we can pick a few columns to actually calculate the distance. So these columns will have real numbers. So for example, lot area, overall quality, overall condition, year built, these are all numbers. So once again, we use a for loop feature in this array. We can concatenate them together. Well, here I'm using a more not so intuitive syntax here. So what I'm doing is concatenating the column I'm selecting together. So there will be 4 columns in total. And by the way, before that, this X string is initialized to be the first column, which is the ID column, so that I have a total of 5 columns here, with 1 column being the ID and the other 4 being these 4 features. Okay, then because all of these are strings, you can see these are strings. Even the numbers are actually strings. So we want to convert all the numbers to integer. So you can do X string as type integer. And for Y train, what is Y value we want to have here? Y is the function output or the model output, which is the sale price, what we want to predict. So Y train will be the last column in this data set. So we simply call the column number of the last column, which is sale price, and that 1 column will be our Y train or our label. And we can print it out to see how it looks like. This column ID, the other 4. Okay, so this makes sense. This is the year built. Okay. And for the label, these are all house price. Then it is the time to get rid of the ID. I have already explained that ID is just useless because that number doesn't mean anything. For example, if this number 765 represents house condition, then this 1, 2, 3 is not something that scales. They're all independent. So we want to get rid of this first column. Now we have the final shape of our processed data set, which contains 4 columns in X and 1 column in Y. Okay, before we do KNN, there's one last thing. We want to reserve some data for testing, right? Because at the end, we want to use some data that the model is never looking for to test the data, to test the final performance. So we define a split index here to be 80% position of the whole data. So we will essentially have 80% of data to be used on training and validation, and the last 20% for testing. Okay, so everything above here will be purely data processing, which you will encounter a lot in the future training, because once you get a data set, what you want to do with it is different from people to people. So that's why you need to process the data so that it's best for your purpose and for the model, for your specific model to process. Okay, let's get into KNN algorithm. Once again here, we have a lot of distance metric. For example, there could be L1 distance metric, an L2 distance metric, and in L1 distance metric, it's simply calculating the difference between each value and sum them up in axis 1. What does axis 1 means that this is the second axis, because axis also starts with 0. So 0 means down in the row direction, and axis 1 means that in the column direction. So for example, if these are the rows, I don't know if you can see my cursor. So if these are the rows, axis 0 will be in this direction, and x equals 1 will be in this direction. So here we're summing up all of the difference in distance of all the features, and finally the output of the distance will be one column consisting of all of the data points. It's a bit complicated to understand right now if you're not familiar with all of the 2D arrays and things, but you will get used to it once you actually implement these codes. Okay, and in L2 distance metric, which is also called the root mean squared error, remember we talked about MSE loss. Here's where we're taking an extra root. We're taking the root is because we have previously squared the error and taking the mean. And finally, we want to root it because we want the error to be the same unit as our data. So this is one of the most common error metric. To do that, we will call numpy.square first to make a element-wise square operation of the distance in the two data points, and we're summing them up, finally taking the square root. And similar here, when we're doing the sum, we also use axis equals 1 because we don't want to sum everything up. We want to sum the row up, but keeping one column at the end. Okay. So let me quickly run this. Well, it won't show anything because I'm only defining the function here. Okay, now this is a k-fold. Scikit-learn has a k-fold package. I commented at the very beginning. But here I just want to write a simple k-fold utility function for me to shuffle the data indices and group the train validation index into five folds, 5 combinations of training indices and validation indices grouping. So we first take the length of data and we set the random seed and shuffle all of the indices. Now the seed here is very useful is because when we are using random, it's not actually random. It's some random number generated by the computer. So if we set seed equals 1 and other people set it to 1, then if you run the same thing, you may get the same results. And that is very important in code reproduction. And finally, we define this variable called fold split, which is an array of all of the possible combinations. So as you can see, there will be 4 portions for training and 1 portion for validation, and there are a total of 5 combinations. Okay, and then finally we're writing one final function for our KNN algorithm. So think about if we have the x data and the y data as the input to the function. So x data being the 4 columns we have, and y data being the 1 column of label that we have. We will test for n k values in order to see which one is the best. But if I type n equals 10 here, it means that if the user doesn't specify a specific number for n, it will just take 10. Otherwise, if user specify a number, it will use that number. but we will let it be n in this function. Yeah, so here is basically the same algorithm that I introduced in the KNN video, but there's one thing different is that I'm using cross-validation, which means that I'm repeating the process 5 times using different training set and different validation set. So I'm looking for my answer in 5 different training sets, and the final loss or accuracy I have would be the mean from the 5 combinations I have. So I will not be going through the codes here because it's fairly complicated. If you want to understand the code here, you could always look for documentation and try to understand it. And here I used a function called arg partition, which will give you the index after a sorted array. So this is a very essential function I'm using for KNN algorithm because we're sorting the distance and getting the index of the sorted distance. Yeah, and finally we have a validation score, which will be the score from each fit, and it will be reporting that final error or loss. Okay, going on, the last function we define is just a plotting function. So to use matplotlib, you can define a plot title. Then if you say plot, the first entry will be the x data, and the second will be the y data, which is the output. And you could also define a label for this. And also we can plot the x label and y label, just put them on the plot, and we can put a legend there. Finally, remember to put a plot.show, which will show the plot printed on this console, otherwise you won't be able to see it. Okay, and here I'm using that KNN regression function using one line, passing the already processed x-train and y-train data, and we specify a number n equals to 10. So in this line, the function will be looking for the best k value that or looking for the score or error of each k value that performs the KNN. So after we get a score, we can call an arginin function to extract the smallest one. Well, the smallest score is actually the smallest error. So we want the index of the smallest error one to be our k. And then we can plot it. After that, we can print out what is the best k and reporting the error here. And finally, remember, we have to do a test to know our final testing error, which we'll be reporting. And this test set is not used for the model to learn. So the decision process of the k is totally irrelevant with this testing set. And we perform exactly the same code with the testing set. We're just replacing the validation with the test, and we print out the prediction for each element in the test set, and we will compare with the actual price in the test set. And finally, we print it out on the scatter plot. But you see here, x-test colon comma 3. This means that I'm only plotting the fourth column of the testing set. It's because it's multidimensional. We cannot visualize multidimensional data on the 2D plot. So I can only plot one column versus one column in order to see it on the plot. So let's run it and see how the result looks like. Okay, here we have the final result. So this is a plot of each k with respect to the actual error it's producing. So you see that the error is dropping quickly when we have more k, which means that more neighbors to compare. And if we compare too many of the neighbors, the performance is actually getting worse because the error is getting large. This is a typical curve you will see in your model training with machine learning or deep learning later in this course. And it's very relevant with what I will be talking about 1 month from now. So if you use a very large k, this error will essentially go up, which means that we are overfitting. So we choose the best k as 4 here because it reaches the lowest point of the error, which means that choosing 4 neighbors to do the comparison is the best on this particular problem or data set. And here we see some examples from the test set. For example, here the predicted price is 153,000 and the actual price is 63,000. Not bad. But we also do see 200k with 600k. That's a big difference. So here must be something wrong with the prediction. But since we're only taking the 4 columns, it's actually reasonable. Now we're seeing large errors. But pretty much for the rest of the prediction, the predicted result and the final result are quite similar. 144,000, 120,000. So I would say the performance is okay, but can it be used to generalize to other unseen data? I would say probably not. And we finally to look at our plot. Remember the 4th column of the data is the year built. So on the x-axis, this is the year built. And all of the orange dots will be truth. All of the blue dots will be our prediction. And you see a trend that as the year built is newer, this house price has a higher potential. And does the KNN algorithm, the KNN model, reflects that? I think yes. So as the year built is increasing, you definitely see an increasing trend of predicted price. So is the model actually learning? This way, I would say yes. And that is the end of this KNN algorithm. I know I haven't go through a lot of details, but I'm encouraging you to run the code and understand each line. And you could always look up the documentation on Python, NumPy functions, and to understand what I was doing there. And here it will be my question for you. There's a huge flaw in my implementation, and it's nothing related to the KNN algorithm itself. This huge flaw will get our result meaningless, or it will hugely corrupt our performance. So what is it? Here's a hint. Think about how we calculate the distance with sum. So when we actually perform the sum of all the features, what's happening? And essentially that will cause a huge flaw. try to give this answer to us, as the thinking process is also the process you are exploring the code and thinking about what each line is doing. That's good practice. And finally, here's a function for KNN classification, just for your interest. Now here's the assignment. So you've experienced some data processing techniques and the basic learning KNN algorithm. So why not just try it yourself with KNN? We have a large data set, but we have only used 4 columns. So you could take more columns, including the non-numeric ones. For example, there's one feature where the data looks like yes or no. You could transfer that yes or no to 0 and 1, and that makes it numeric. So you could do whatever you want with the data set, taking as many data as you want in order to train your KNN. And this is a good practice of manipulating with Python and NumPy, as we will be getting into intense training very quickly in the next session. So as I said before, you will not submitting the assignment to me, but rather submitting the assignment to the Kaggle competition, and you will immediately get a result about the score and your ranking in the leaderboard. For example, my ranking was like 4,400, and I was in the last 10% of the leaderboard because I'm using the KNN algorithm. I'm not using any machine learning or deep learning yet, and I only use 4 columns with it. So, am I satisfied with the result? Yes, I certainly do. And here's a sample code on how I actually produced a submission file. So you load the test file. It's not the testing set we're using above, because that testing set is extracted from training set. So this test set is exclusive, which doesn't give you sale price. You need to predict that yourself. And I use the exact same method. Use the training set to find my final prediction and compile it to another CSV. The additional step you will do is to add the first row, which is the string, the text of ID and prediction. Then you can submit your file. So if you have time, definitely try this out. I know this is not very beginner friendly, but I'm trying to make this as easy as possible, because in the next 2 weeks we'll be getting into the actual machine learning codes and actually using PyTorch to train a very, very easy example. So before that, you must get yourself familiar with Colab and Python and NumPy, and that will prepare you with the later study in this 101. So as usual, I hope you enjoyed this video. Do not hesitate to post any questions, and good luck with your training and assignment, and try to win the prize for a good score in submission. So good luck. See you in 1 month.